All right, good afternoon, everyone, and thank you for coming here on day 4 of the AI House. My name is Kirk Bresnicker. I'm Chief Architect at Hewlett Packard Labs, and I'm your moderator today. Thank you for coming here in late afternoon. I know this is the last panel of the day, but I'm really excited to introduce you to our panel members who are here along with me. We have Ann Durkin, the former Chief Information Officer for the U.S. Department of Energy. We have Melanie Nakagawa, Corporate Vice President, Chief Sustainability Officer from Microsoft. Cully Kavnes, Co-founder, President, and Chief Operating Officer of Crusoe. And my colleague from HPE, Monica Batchelder, our Chief Sustainability Officer. So thank you, panel. It's funny sometimes in my web experience as an engineer, as a technologist, I kind of sometimes feel like a fish out of water. The kid from the vocational college who somehow finds themselves at the Oxford graduate program for international studies. So, and I'm glad to have a fellow engineer, a professional engineer, sitting next to me today. But our topic today is, can we resolve the paradox of sustainable AI? Underlying that is sustainable IT. But a couple of things for me, in my perspective, both at Hewlett Packard Labs, as the head of our responsible AI working group, we think about sustainability, and for me, I think about sustainability as satisfying current demands while not precluding future generations from satisfying their demands. And in the context of this age, we find ourselves, literally in an age of wonders. But I'm also a student of engineering history, and I remind myself, and I remind others, 100 years ago, we were also in an age of wonders. Then it wasn't AI, it was chemical engineering. And we think of tetraethyl lead. We think of the ability to democratize cheap and expensive personal transportation, raising the long-term economic opportunities of an entire population. We also think about chlorofluorocarbons. We think about the ability to preserve food, to preserve medicine, to provide comfort and shelter to people around the world. And then we think of that one chemical engineer, Thomas Midgley, who invented both of those. And they were fundamental in providing some amazing technology, amazing outcomes, until we could trace lead in our baby's teeth and correlate it to their impeded intellectual development, until we got a hole opened up in the ozone above the Antarctic. And why we have learned how to mitigate those particular individual engineering choices, by the time we got there, we had built up so much around the economic reality of those systems, of the transportation system based on fossil fuels, around refrigeration based on chlorochemicals, that we couldn't back ourselves out. And so we think now in terms of AI, as we begin to embark on perhaps some of the largest engineering and investment programs we've done as a species. Can we begin to think about those impacts? And specifically here, when I think about sustainability, I'm often hearing things and they give me that cognitive dissonance. So when I hear someone say clean coal, it kind of makes me wonder. It makes me think again. And we want to think about sustainability and AI. So we have a great diverse panel here. People, either from the bottom to the top of the stack or elements of the stack. So I'm going to be probing each of you to one, please talk amongst yourselves. Don't just wait for me to call on you. But also, as you listen to the prompts, think about how you're communicating both up, down, and out. How you're having these conversations about sustainability, and how you make those vital connections between technologists, between the public who is hopefully not just made safe, but has their opportunities raised, and also as you talk to your regulator, your team members, that broader community. So with all of that, the first question, and let's start this way. AI is an opportunity and a challenge. It's, again, that which one is? Well, it's both. And so how do we begin to resolve this? How do you resolve that paradox of sustainable IT in the context of your organization? So what does your organization need to understand so that cognitive dissonance can be resolved? They can hold both AI and sustainability in their minds at the same time. And could you
Yeah,
lead us
so
off?
so I'll talk about this, and keeping in mind I left DOE on Monday at 12:01 p.m. Gets a laugh in every room. So that I can still obviously can still talk about DOE, but I also think that this is applicable more broadly. So you think about DOE, it's a bunch of things we do. And I'm not going to go through all of them because they're not all applicable, but one of them is that DOE runs the energy grid in 36 states. They sell bulk power that's generated by other parts of the government, and runs 17 national labs that do everything from basic physics research to applied research, from classified research to open science. So in that context, when I think about AI, I think, so AI uses a lot of energy. However, AI is going to advance our research in all of these fields, that many of which will lead us to a more sustainable future. So AI is helping us create fusion energy. So DOE runs, it was one, now it's all three of the fastest supercomputers in the world. Frontier's the fastest. I can't remember the order of the other two, but they're the three of them now.
Capitan's the fastest.
You would know because you sold it to us. El Capitan's faster than Frontier now. You were right. Sorry. Frontier was fastest for a very long time. So El Capitan's the fastest, and then I think the other new one, and then Frontier.
Yeah.
But anyway, we have the three fastest, and all from HPE, as you might have guessed. So those are good, but without adding AI to them, we can't meet all of our needs. And so when we look at, for example, Fusion, as I said, when we have two versions of Fusion. We're looking at the NIF, which is at Lawrence Livermore, and at Princeton Physics Lab, we have a tokamak reactor. And so we're testing both. And what we do is we do a lot of modeling first. So all science is computational now. Even if you're doing a physical thing, you're going to do computational work to design that and then to evaluate your data. And the more computing power, the more AI capability we have, the more that speeds up that work. So AI is helping us bring fusion to the market faster. It's helping us find better substrates for solar panels, better battery materials, helping us model and identify where there's good sources of geothermal energy. I mean, we model traditional nuclear reactors as well for small modular reactors. So all those things, to me, that's how you solve the paradox, is you use those tools to help you develop and improve renewable energy.
Melanie, you represent such a broad organization at Microsoft, and not only a global organization, but that footprint, all the elements. What about that incredible breadth of people that you need to communicate to?
So I think for us, and I thought Anne did a great job of talking about both sides of the ledger, that's particularly relevant for a company like Microsoft. And so the way we think about it is, first and foremost, what are we doing to ensure that the build and the usage of AI is done with sustainability principles baked in through the entire tech stack. So it goes everywhere from how you build, operate, and apply AI is how we think about sustainability within the stack. So the build part is ensuring that both the physical build of data centers is being done by trying to find and source the lowest carbon products. So looking for green steel and green cement. We invested through our Climate Innovation Fund into the Swedish company formerly known as H2 Green Steel, now known as Stegra. They're producing a steel that is 95% lower carbon than conventional steel. So if we can get that commercially viable and commercially scaled, they're hoping to be in production by next year, and getting that into these builds, it's going to lower the carbon footprint. We're looking at programs with Sublime, which is a low-carbon concrete company, as well, to see how we can scale that industry. The next part of build is thinking about how you build the models. How do you build the models with efficiency in mind and energy efficiency in mind? And then it goes to the application layer. So the application layer, actually I should also add, it's also the application around energy. So how do we ensure that as we grow demand for data centers and we grow capacity for them, we're bringing on as much energy, new energy to the grids where we go. We're ensuring as much of that can be carbon free, and then ensuring that we can pay our way. So to date, we've done 36 gigawatts of clean energy contracts for net new clean power to power these data centers. We're continuing to grow that portfolio as we grow. So that takes care of the first part about to your paradox of how do you ensure the energy inputs to create the data, to create these data centers that create these models, can be done with sustainability baked in. The second part, which we still have yet, we're only at the very beginning of, is what do these boxes do? and gave a few great examples of what AI can be doing today, how you can apply it to really dramatically transform the energy system. Let me give you one granular example. So with the Pacific Northwest National Lab, a DOE lab, we partnered with them using Azure Quantum Elements and AI. And what we ended up doing was we looked at 32 million material candidates for a new type of battery. We narrowed it down to about 12 and then got it down to a final candidate. And that process took 80 hours. So consider one long weekend effectively. That process and that iterative process would have taken years to actually get from 32 million down to a single candidate, and then to actually create a battery that can power like a light bulb or what have you. And so that's just a great example of the rapid scale and power that AI can have. The other example I'll share with you is line vision. It's dynamic line rating. You hear a lot about the need for more transmission lines, more clean energy. While all that is true, we can also use our existing infrastructure better. So line vision uses AI with utilities to bring on more capacity onto existing transmission lines. They deployed in the UK national grid. They brought on 600 megawatts of more offshore wind, increasing the capacity by 60%. So this is just the beginning for a company like that. So it's these kind of examples that I share because we really are at the beginning stages of what the use cases for AI can be to dramatically transform and accelerate our clean energy transition.
Right. Golly, engineering those AI data centers for you and for Crusoe. How do you have that conversation both to your customers as also to your partners who are helping you execute those designs?
Yeah, I think this question of the climate and environmental paradox around AI is really a fascinating one, and one that we think about a lot at Crusoe. I think framing it as both sides of the ledger is a great way to sort of analyze it. So Crusoe, we're building vertically integrated AI infrastructure. We build data centers as well as a GPU cloud product. And on the sort of emissions and energy consumption side of the ledger, we take a very energy-first approach to where we site our data centers. And try to take it a step farther than purchasing like virtual power purchase agreements or renewable energy credits, and actually physically locating our data centers in places where they tie into physical energy infrastructure in a way that actually solves some kind of environmental or energy market problem. So some examples of that are we've located our largest GPU cluster in Iceland, where it's 100% powered by geothermal and hydropower. We're under construction on 206 megawatts of AI training data center capacity at a node in Texas that historically suffered from a lot of curtailment of wind power and negative power pricing. So by putting that load at that site, we can actually reduce the amount of wind power that's otherwise curtailed or wasted. And our company's roots actually go back to capturing flaring natural gas in the oil fields, mitigating methane emissions and energy waste by generating power from natural gas that was previously being burned wastefully. So we take a very sort of energy first and first principles approach to where and how we site our data center loads to try to bring down the cost on that side of the ledger. And on the other side of the ledger, I think this is what's a really interesting open question is how much like climate payoff will there be for the bet we're making in terms of incremental emissions. So just to frame it, I've been thinking about just trying to put it in perspective. The data center industry today in the U.S. consumes about 200 terawatt hours per year of electricity. McKinsey and Company would project that that's going to about 600 terawatt hours per year by the end of 2030. In the grand scheme of the U.S. Electric grid, that would be going from sort of low single-digit percentages to maybe up to 10% of electricity. But if you back up and say, what about primary energy, which is really, if we're thinking about emissions, it's sort of like the total energy consumption, which would include heating and transportation and industrial uses of energy, not just electricity. The U.S. economy consumes something approaching 30,000 terawatt hours of electricity per year. So even at this sort of like aggressive growth case by 2030, we're talking about the whole data center industry, not just AI, but the whole industry consuming something like 1 or 2% of primary energy in the U.S. So I think it's important to focus on making that less emissive and less impactful. But that's sort of the bet we're making. We're probably making something on the order of like a 2% incremental emissions bet. And then the question is, what kind of emissions reduction will the payoff be? And here we're sort of venture capitalists. I think there's like a scenario where none of these awesome ideas pan out. That would be the downside case. We would have added emissions for no payoff. But I'm very optimistic that there are a lot of reasons to believe it could be fusion. It could be better batteries. There's a company working on Crusoe Cloud searching for better direct air capture materials that can extract carbon from the ambient air. So if any of these pay off, it could be 10, 20, 50% reductions over time. And I think if we were venture capitalists, we would sort of say that's a good risk-adjusted return. We should invest a little bit of incremental emissions today and work very hard to make sure that these payoffs happen in the future.
Yeah, so let me add to that, right? To be clear, when we look at DOE, we're not just looking to mitigate AI's costs. We're looking to use those to help us get back to, we're probably going to exceed 1.5C, but to get us back down, right? And that's going to be obviously reducing the emissions in all those areas, but also carbon capture, because to get back down, we're going to have to do carbon capture along with lowering the emissions of everything else. And I think, to your point, I use your example of the Microsoft project a lot with PNNL. We are going to have quantum as well. It's going to not just be AI.
Yes.
Monica, do you want to finish this off?
Sure. I think we talk a lot about AI's potential to transform industries, and we're all waiting. You just mentioned fusion. There's a lot of breakthrough things that could be coming, but there's a lot of ways that we're already applying AI right now, and I think these are all three examples of how we're doing that. So, it's not just about waiting for the next big thing that's going to bring down carbon emissions, but then the other opportunity is using this as a moment to also rethink the underlying infrastructure behind AI. We need to be rethinking how we're going to power, cool these new GPUs that are using an insane amount of energy. And so as sort of the underlying infrastructure provider for AI, so to speak, we're really thinking about how we rethink the energy efficiency equation and how we help to actually understand the true costs, because I think, especially if you're not one of the big users, you actually don't really see a lot of the sort of environmental impacts of AI. You're not seeing the energy bills if you're using pre-trained models, which is most of our customers. So how do we help them understand the true costs, the environmental and the social costs, and bring down sort of the energy of AI, but also ensure we're doing it in a way that doesn't dehumanize people?
Fantastic. Now, the next thing I'd like to probe on is a little bit more and deeper into tech. And I think so much of what we've already said. When I think about, I'm inspired by someone in our backyard, which is the NASA Ames research team. And one of the things that they've talked to me about was there was a point in which they had some of the best wind tunnels in the world, and they were designing amazing aircraft with those. And then there was this little plucky team who was trying to do this computational fluid dynamic stuff. And at first, it wasn't even good enough. Then it was comparable, and even though people were saying, we got a perfectly good wind tunnel, why don't you just use that? And Melanie, this is just what you've just described here. As soon as it transcended, suddenly it wasn't just that I could do the same thing on the computer that I could do in the wind tunnel. I could do generations and generations. What would take a lab of professionals 100 years to do, suddenly it could be done automatically, and all those degrees of freedom we could explore would be suddenly available to us. And then when we think of quantum, we think of adding that ability to model the Newtonian world with the world of Heisenberg and Schrodinger, and bringing that quantum capacity. So when we have to engineer at the quantum mechanical level to solve these incredible problems, then that's what we're looking for. And what's also important is to realize that AI might be a way we get to that understanding faster, both to get better qubits and to scale that technology. But as we think about continuing to optimize that tech, and you mentioned efficiency, and I'm going to ping you since you're my CSO. When you think about that technical efficiency, how are you working with the technology teams? Engineers, my favorite quote from one of my old-time mentors at Hewlett Packard is, an engineer does something for a nickel that any fool could do for a quarter, right? And it's that optimization, but you have to know the boundary conditions. Boundary conditions to an engineer are a blessing and a challenge. It makes the problem that much harder, that much more satisfying to solve. So when you're talking to our technical teams, Monica, and you talk about that technical efficiency, how are you walking them through what they need to understand so they can be prioritizing correctly?
Yeah, I think one of the challenges we see is that we are solving for piece parts of the equation instead of the whole system and the whole solution. So we talk about, facilities impact. We talk a lot about energy efficiency. What we don't look at is the trade-offs between all of these things. So, just as an example, you raise the set temperature in a data center, your fans are spinning faster, you actually might be using more energy. And so this next generation of accelerators, fewer and fewer GPUs are going to be able to run on air cooling, for instance. So we need to be innovating new technologies where we have new cooling systems. We have sort of more efficient chips as well. But it's all those trade-offs. It's looking at, do we need all the information in the world to be able to translate something from English to French? No, right? Like we need to right size the models. So there's a lot of different trade-offs that we're looking at, and we're trying to help our engineers, back to what I was saying about the true costs, is get the data to understand how to design for that from the start, but to think about the whole life cycle, the development, the deployment, and also the trade-offs between them.
Who wants to go next?
Sure. So similar to what you were saying, we're looking at, well, one of the things we've announced last year was all of our new AI data centers will be zero water for cooling because we're going to use liquid cooling. And it's exactly that, right? These new chips are hotter, and so we found a better way to actually cool them using a technology that puts a liquid onto the pallet and cools it that way. And so that's really interesting because what I get excited about is these new generation of data centers that are being built. We haven't seen them yet in the wild, and so we don't have all the data yet as to what they look like in the wild. But early studies are showing that if you've got a zero water cooled data center, it's going to use less water, which is great. The other piece too that we're looking at is the small phi. So small phi is our latest model that came out, and it's a small language model. And these small language models, or SLIMs, is a great example of ways we think about efficiency and energy efficiency, and then it also leads to emissions efficiency by being able to build these smaller models or agents and other things to be right-sized to what the issue is. But of course, when we started with large models. We'll continue to do large models. But again, this industry is really changing in real time right now, and efficiency is a key part of it. The new chips are also just wildly more, they're almost exponentially more efficient with each new generation. So it's doing more computational compute with less power. So these are all just sort of key components. And again, we're really at the start of this. So it's hard to take a look at the 1.0 and draw a straight and multiply that out by the growth because those numbers are going to change. I love the way you started the conversation about history, right? You think about history. And I think one of the things that I'm always reminded of, obviously working at a technology company, is the team that talks about the very first computer, and it would take up a room this size. And now a phone has more computational ability than that first computer. And so really, you've got this aspect in technology where things do get smaller and more efficient by the nature of the industry and the business. And that's what I think, gives me optimism, but also makes me feel like this, this era of AI, we're just getting started, and you're just going to see more efficiencies as it grows.
Fantastic.
Yeah. So, with the Department of Energy, the interesting thing is we're not focused on sort of solving every problem in one place. It's like I don't have to optimize a single data center for everything because we have this broad research mission. So, for example, at National Renewable Energy Lab, their high performance computer is got an exceptionally high POE, and it's or exceptionally low POE. I probably should say it that way. But they're nearly 100% efficiency, and one of the reasons they're nearly 100% efficiency is because they use the waste heat to heat the building, right? And they loop they loop the water back through the building, heat the building, and so they're very, very much able to meet that need. And so we look, we're testing and trying different things across the enterprise, and then those best things get out to the market. One of the other things we do is at Lawrence Livermore, they've done a lot of research in how to make data centers most efficient, and they've published those tools online. And so if you're designing a data center, you can go out and grab those tools online and evaluate your data center designs on Lawrence Livermore's tools and figure out, either when I'm building this data center, what should I do? Or once it's built, how can I continue to optimize that data center? So we approach it from a little different angle because of the research mission of DOE. But one of the things I want to sort of add to everyone else is small language models. I think, not only do you not always need a large language model, I think you point out it's more mission efficient if you've only got the information you need in that model. So we all love these huge models that know everything. The reality is that most of the time, you want to know a little bit. So the model we built, for example, to help small businesses navigate the Department of Energy doesn't need anything but information about how small businesses can navigate Department of Energy, and anything else is extraneous and potentially confusing. And obviously, training those is much less expensive. It's much less computationally intensive. And so I think now that we've gotten through being super enamored with large language models, we can all step back a little bit and go, okay, what do I actually need? And use that. And then the other piece of that I had a conversation about this morning is figuring out how to train large language models more efficiently. That every time there's new data, you don't retrain that entire model, but being able to train on incremental data. So there's a bunch of different things we're looking at across DOE to try and improve those capabilities, and then share those out to the whole world.
Kelly, you form a center of. Oh, wait, Monica wants to jump in first.
I was just going to add one thing because we were talking about sort of extraneous information and small language models. The other thing to keep in mind is that right now we're just using AI for everything. So how do we think about when AI is actually the tool for what we're trying to solve? There's an analogy that using AI for simple applications is as efficient as driving a race car to the grocery store. So I think that's the first and foremost thing. We're talking about how we sort of train our engineers to think about these things, but how do we actually educate the end user as well to understand when they should be using AI and what sort of size language models to use as well?
Kelly, you form that center of excellence, Monica, times for people coming to you, with a challenging problem. And how do you have those conversations with their technologists to better educate them and to so that they know how to best take advantage of the work that you and your team are doing?
Well, I think actually your original question was also about how do you speak to our own teams.
Yes.
So maybe I would even start there. Is we're about 630 employees at Crusoe. We have a hiring plan to about 1,000 by the end of the year. We're still a small company compared to the other organizations on the stage here. And I think at an earlier stage in our history than maybe would have been expected, we invested into crafting a set of mission and value statements. And so a lot of those spoke to sort of environmental values. One of our 5 core values is relentless commitment to resource efficiency. So we bring this up very continuously in monthly all hands and other meetings. It's like heavily emphasized. And that has a variety of principles around financial efficiency with resources, but for sure energy efficiency and emissions and making the most of what we do use and the impact we do create. We also invested probably earlier than a lot of smaller companies would have into a full-blown ESG report and all the consulting, full scope 1 through 3 carbon accounting as a private company. And we use that to educate our own team internally about where are the areas where we sort of make a great beneficial impact, and then where are we maybe needing to improve. For example, we have a lot to learn still on embodied carbon and the construction side. I think we're very energy first thinkers, and now we want to build with better materials over time. So we have sort of a learning curve on that side of it. I think when it comes to interacting with our counterparties and business partners, which I think is the question that you're asking, it really comes to, I think, just like laying out the numbers in many cases of what do we think is the actual physical impact of putting a data center here compared to somewhere else, and providing some analysis on why the emissions per kilowatt hour is probably the most important driver of emissions in the lifetime operations of a data center. Embodied carbon matters a lot, but if you get that wrong and you're on a dirty energy source, it'll vastly outstrip the other emissions. So we'll just do some analysis, and a lot of these counterparties are pretty technical. They like the numbers.
So many paths to failure and a narrow path to success. Yep. And I think that's, so much about what we've just said here reminds me that this has to be a holistic solution. We mentioned the small language models, and one of the areas of research that we're looking at Hewlett Packard Labs is every time we do an inference, we take a model weight and we take a piece of data and we move them across the surface of a GPU, and they end up in a multiply unit, and then they go to an adder. It takes more energy to move the data from one side of that chip to the other than to do the math. And when we think about that model, it's constants. We figured that out when we trained it. We have new technologies, non-traditional compute models. Now, they can't handle the biggest models, but they can handle a modest model, and they store the weights in non-volatile memory. So we write it once, and then we get to amortize that information, that energy usage over, hopefully, in perpetuity. So but it takes everything to come together. It takes the chip, it takes the software, it takes the engineering, and then they have to be fully informed of all the things that you just described, from the building of the facility all the way to the end user, and being cognizant. And I try not to be an optimist. I try not to be a pessimist. I try to be a realist, because that's a good engineer. But something in me says, when people have the data, I like to believe they make the right decision as a community. So hopefully this is talking up to the community that we need to really be forming. All right, the next question is, and you've already touched on this a little bit, Melanie, but it is that energy equation and how to find the balance points. Where do we account for it? And I know, and you also mentioned PUE. And one of the things I always think about that, I think that's a fantastic measure. It tells me how much of our high quality electrical joules we turn into low quality waste heat that we somehow still manage to do something useful with. But if something's not worth doing, is it worth doing well? That question of, as we look at all these things, are we cognizant not only that we're efficiently moving the energy through the systems we've engineered, but that we understand the absolute value of the energy, especially when it becomes something that we need to understand that sustainability angle to. So, Melanie, can you take that next click down into your stewardship over that energy equation?
Sure. So as I talked about build, operate, apply, I'll just click into that another level. So again, on the energy equation, it really is, if you think about it from a pure energy perspective, it is things like, how do we find as much power and bringing on power to where the load is growing? So an example of this is what we announced last year, which was the restart of the nuclear reactor 3 Mile Island and the Crane Energy Center. And what this was is there were 2 reactors. One was shut down for safety reasons. The other one kept operating for years afterwards, but was shut down due to economics. And when you look back at where we are today, we realize that Pennsylvania grid, that market, the PJM market, where AI growth is going from a variety of hyperscalers, it was a congested grid, and we knew we needed to bring on more power and net new power into that system. And this reactor was 800 megawatts of carbon-free power. The infrastructure already exists. The workforce is there. It needs the interconnection. And so this was just a great opportunity for us to partner with Constellation to bring back that facility, and therefore bringing onto the grid 800 megawatts of carbon-free power into a grid that we know will need more power, and we want it to be carbon-free. So that's one way we think about energy. It's also the reason why we're at 36 gigawatts to date, is we're constantly looking for places where we can add net new carbon-free power to the systems where we're growing. The other piece outside, and then I should also add of note, which people don't often realize, for Microsoft in our annual report, when we do our sustainability report, 4% of our net emissions, or 4% of our net carbon footprint is actually from the energy that we buy or use. But 96% of our footprint is actually from our value chain and supply chain. So really the bulk, when you think about, how does Microsoft become carbon negative by 2030, 96% of that ability to get to carbon negative by 2030 is coming from the physical build, the embodied carbon in the data centers, the chips, the steel, the concrete, the fuels that we travel with, but that our products like Xboxes and Surfaces, laptops travel, and it's indirect procurement. So I think that's been, when you think about what we need to do, yes, there's an energy equation, but frankly, for us, it's really, when I think about the environmental footprint, it's that 96% that we're really trying to find all the ways to reduce for. The other piece, obviously, is going to be on working with our engineering teams on model development, model training, and thinking about efficiency in that. And I think for a lot of our teams, they're already incentivized to be efficient because you're charged for the cloud usage to begin with. So there's already a built-in check into the system to ensure that we are being as efficient as possible. But it is going to be for sustainability players like myself, it's really going to be on where are the biggest levers that we need to pull to get to carbon negative. And right now it's looking like the indirect procurement side.
So if I was sitting at my laptop engineering at Microsoft, do I have the telemetry and the understanding necessary to make those decisions? I could do A, I could do B. There's lots of other constraints I'm trying to satisfy. I know this is something that Monica and I work with at HPE, understanding how we instrument the teams and give them that understanding. Because again, I'm confident the engineers are going to make a good decision when presented with the boundary conditions and the information to solve.
I think it's a great question, and this is one where I think a lot more collaboration and partnership is needed, because this is the kind of, that level of insight at that level of training, I think is really critical. And, there are ways you can think about follow the sun software where you can train based on where the grid is greener. We use telemetry on Xboxes and Surfaces in terms of when we push out updates. If you select the energy aware feature, you'll get your updates pushed to you when the grid is greener. So there's ways that we're doing this now, same with Xbox as energy aware software. So on the consumer side of the house, there's ways that we can give the consumer that level of visibility to pick and choose. I think on the engineering side, when it comes to these models, that's the next layer of growth for us, is to make sure that they all have that level of specificity to know you can pick your training site, you can pick how you run it, you can pick those different components.
Monica, what about our conversations at HPE on the energy equation?
Yeah, so I've been here for 4 days, and every single AI sustainability conversation has focused entirely on energy. So I'm glad we started with efficiency. And it also is, fear mongering and essentially saying that, AI is going to use up the world's energy supply. And I don't think anyone up here thinks that. I actually see this as more, let's use AI as sort of a catalytic moment to decarbonize the grid. So to give Melanie credit and all the other hyperscalers, the companies that are driving sort of the AI workloads are the same companies that have the most aggressive climate goals, that have the funding to drive that decarbonization. And so I actually see it as an opportunity for us to accelerate the decarbonization of the grid, to improve a lot of the resilience of the grid. We've talked a lot about supply and demand, load shifting. Yes, there's trade-offs there. Sometimes maybe shifting the load and the AI computation to decide whether to do that and to actually shift it may be more energy intensive than just leaving it where it was, right? So that's back to the data. But I actually think this is an opportunity, if we're equipped with the data as we've been talking about, to make those trade-offs to actually catalyze the decarbonization of the grid.
But as in so much, we mentioned you follow the sun. Part of the challenge sometimes, especially when we're talking not only about training, but especially when we're talking about inference. With training, I can have a very efficient electric vehicle drive up a load of SSDs and drop the data off where I want to do the compute to train. When I'm inferring, I need to bring new data into that pre-trained model. And when we talk about data movement inside the data center, picojoules. When we talk about data center across the wide area network, millijoules, 100 million times more energy per bit to go from A to B when you go over a wide area network. If I already have pre-staged the data, where the computation is, then I can follow the sun. But otherwise, I might find myself spending energy to move to where the sun is. And more largely, when I think about energy, when energy is available, are we going to see the new AI build-outs very efficiently, very completely consume all of that new sustainable energy? And will this allow us to take the other 95% of the grid that is not focused on AI, that's focused on keeping us healthy and fed and transported and entertained, and decarbonize that? Or is this going to find ourselves that all the great ideas are going to be put only into AI?
Just me? Yeah, I mean, the
I'm going to ask all you.
projections are, 4%, depends what source you use, 4% of greenhouse gas emissions. How do you apply that to the other 96%? And so to my point earlier, we don't need to wait for fusion. We don't, we're doing a lot of research in that space, and it'll be a great breakthrough technology, but we're already seeing efficiencies across manufacturing. We're seeing new low carbon innovations. We're going to start to see moving away to the point on embodied carbon. Instead of using copper wiring, we'll see silicon photonics, which our labs team is researching right now. So again, I think it's using the AI application, and I think there's probably unanimous consensus here and in every sort of panel and discussion I've been in this entire week that the applications and the sort of benefits of that are going to outweigh the energy use.
I agree with this idea that we don't have to wait for big breakthroughs. There's incremental efficiency along the way. I think one of the reasons to be optimistic is if you just look back at the previous computing revolution and what that did for efficiencies, which is a very important keyword here that does, not find its way into the conversation maybe as much as it needs to. I think about, the original combustion engine, and these were sort of like sub 10% efficiency things at the dawn of the Industrial Revolution, converting basically fossil fuels into mechanical energy, and most of it went out as heat. And then there were refinements and improvements over time, but we never could have gotten to 60 to 70% efficient combined cycle natural gas turbines without computational fluid dynamics.
Right.
So what is that? What is AI going to do along those same lines for existing energy systems, make them take that next step. It doesn't have to be a total breakthrough. I think a lot in terms of Talley's law, this principle of environmental economics, resources times technology on one side of the energy equation, population, quality of life, and environmental health on the other side of the equation. So if we think we want rising population, rising quality of life, how do you not have to compensate with environmental degradation? Natural resources are static, so it's technology. And so by improving technology, we can have rising population, rising quality of life, and same or better environmental health. It's that T variable in RT equals PQV that hopefully AI is like unlocking a lot of that, whether it's incremental or breakthrough, that makes the rest of the equation balance out.
Right. Yeah. So we look at it, from the energy supply side and the energy demand side, right? And so on the energy supply side, we put energy into all of the above, right? Clean energy, and that is, everything from nuclear, which is bringing back some of these nuclear. Well, actually, I think you're the only ones restarting a plant. We've been trying to keep some running. I don't think we're restarting any, except for Three Mile Island, but we're going to get those plants continue to run. Meanwhile, looking at developing small modular reactors, getting those to market, finding more geothermal sources, getting those to market, moving clean energy from where it is to where we need it efficiently, or in some cases, if you can, moving the demand to where the clean energy is, right? So your data center in Iceland, which one of you is good? Yeah, your data center in Iceland, right? You don't need that data center in the US. You can move the data. So when you're done, so both of those on the demands on the supply side. So we can provide an increasing percentage of clean energy across the grid. We saw our colleagues in Portugal. Anyone from Portugal here? Nope. Portugal ran their grid for 3 weeks on 100% renewables last year. So in the US, our labs said, wait, the grid starts to break at 35%. I'm like, well, let's go talk to the Portuguese and figure out how they did that, right? But it's doable, and we can do the modeling to figure out how to run the grid under those circumstances, how to have the base load that is clean and renewable, so that we can support the fluctuations in those areas where it fluctuates, like wind and solar that aren't constant. So there's the supply side, but then the demand side, we work on technologies at DOE to reduce the cost of computation, to increase the energy efficiency of driving your car, whether it's electric or whether it's gas, right? Whatever that is, we're trying to make all those things work better so that we are providing clean energy to the grid, but we're also using less energy in the grid. And I think that's what everybody here is trying to do.
Any last thoughts, Melanie?
No, I think that's exactly right.
Perfect. Yeah. So I want to take the last couple minutes and give you each a chance, reflecting, as you've already shared, Monica, reflecting on the conversations you've had here. Is there one conversation that you want to share with everyone who's here, or is there one conversation you would have liked to have had, and is there something that you would like the audience, both here and who will be watching us later, is there one thing that you want them to take back to their organizations? Again, talking up, talking out, talking across these organizations at that intersection of AI and sustainability. And we'll start with you.
Wow, you asked me this earlier, and I still don't know that I've got my complete answer. I think there are a few things, right? Number one is, I'm not sure it's going to be one conversation, but the number of people I've talked to, the number of entrepreneurs who have new and interesting technologies. I've talked to people who are going to reduce the computational, change the computational methodology for AI in a way that will reduce the cost and be able to do some of that work on CPUs instead of GPUs. Folks who have created the capability to bore tunnels with energy as opposed to, well, it's all energy, but instead of a big boring machine to use heat and to do it that way, and the potential to bury many of these cables in the ground. People are finding new ways to be more efficient with geothermal energy. Just all these great ideas, and all these entrepreneurs who are here. Helps remind us that climate change is not an intractable problem, which is super important since we just pulled out of the Paris Climate Accords, that we need entrepreneurs to solve this problem because the U.S. government's not going to. Yeah, sorry, that was a downer. I guess that's the and this conversation. I will segue into the conversation I've had with a bunch of people But I will continue to remind people, right? The U.S. government is not going to drive what happens with energy and renewables in the United States. It's going to be industry, and it's going to be the state and local governments that are going to continue down the path. So I don't want anyone to think, yeah, it's bad that we pulled out of Paris Climate Accords. Arguably, we weren't exactly meeting our obligations anyway. So, that's another conversation. But that's not going to stop people in local governments. That's not going to stop the state of California. It's not going to stop Microsoft or HPE or anybody else from doing the right thing to move us forward. Bad things will happen over the next 4 years, sadly. And now I'm the free agent, I can say that. But don't lose hope about energy. So I probably did not say that to enough people enough times this week. So,
Melanie?
I think I take a similar, an optimistic perspective, which is, there's a lot of sort of gloom and doom. I mean, that people can apply to with AI, a lot of the uncertainty or concerns. But I think the conversation I've been having and I continue to have is the two sides of the ledger, which is, companies like ours are going to manage, like heck, the sustainability footprint of AI growth. And we have strategies and tactics and a real roadmap to ensure we can grow responsibly. But at the same time, it's up to everybody in all the rooms that I'm in to think about use cases of how they can use AI to develop new solutions, to increase their own productivity, all the different ways that people can be adopting this solution. I mean, one thing that we often talk about, we have a feature called Copilot, and it's not, the Copilot that's going to take over the world, but it's humans using the Copilot. And so it really has to be human enabled. And so really thinking through what are all these use cases? Because again, we're just at the starting point of some of these entrepreneurs that are using it for geothermal or different types of energy solutions or new technology development. And that's what I get really excited about, because I think there's so many entrepreneurs here and people, even what's great about some of the work that we're doing is it's also upskilling a workforce so that you don't need to have a geospatial degree to query a system to understand what's happening. You don't need to be a statistical expert to go through a pivot table in Excel anymore if you can just ask the agent to create this for you. And so it's really kind of democratizing data and democratizing skills in a way that we have never seen before. And for a workforce, we have sustainability teams, but now we've got the ability to create sustainability expertise throughout an entire employee sector, not just the ones that sit on the CSO's teams. So that's where I think there's a real opportunity here, is for people to walk away and think, okay, let me go play with this tool a little bit and see how can it help me and my business, or how can it unlock a challenge that I have. And that's the kind of conversation I'd love to have more of, is to hear all these different solutions people are doing. I talked to someone today. They had created an AI robot to install solar panels. Nice. And now this robot can work in hot temperatures, because often hot, sunny locations is where you have a lot of solar. And so now you've got this robot that can take these 65-pound solar cells and install them onto the racks. And just what a great improvement. Now there's a human in the loop, of course, but at least now you've got a better quality and a faster build of solar than we've ever seen before. So there's these really cool innovations that are happening today using these various chips to create sort of unprecedented unlocks.
Ali?
Yeah, I think my comment would be that I'm just really eager to see more of these use cases, especially as they're applied to environmental, energy, and sustainability end products, or products that are related to impact there. So mine would really just be an invitation for if there are founders, if there are entrepreneurs or companies that are innovating AI products that require GPU computing, and especially if you're trying to build something that has a sustainability element to it, I would love nothing more than for Crusoe Cloud to be like the preferred home of those innovators to build their AI and train their AI. And I get really excited when I hear that somebody just onboarded, they're looking at new battery chemistries, or the direct air capture materials example. We have a company that's using AI to work on fusion. Those get me really excited. I'd love nothing more than for Crusoe Cloud to be full of those kinds of use cases. So yeah, just an invitation and open door, especially for those kinds of projects.
Yeah, Melanie stole mine around figuring out how you can use AI, but I'll sort of double click on that, which is something I've heard a couple times this week, is that technology and innovation and the need to invest in that is going to detract from sustainability budgets. And so I would challenge everyone to challenge that assumption and figure out how they can work together. We talk to customers all the time, and we have CIOs and CTOs who do not know their own chief sustainability officer or even know that their company has a chief sustainability officer. And we literally go into the room and we introduce them to each other in the same company. So I don't want to do that anymore. Go find out who your peer is that has aligned objectives and figure out how you can work on these things together.
And I think I will echo that. One of the things I find is that I'm surprised sometimes, again, back to being the kid from the vocational school at the School of International Relations, there's pieces that I can add to the equation, right? I might not know the intricacies of international treaties, but I know Joule's law, I know Ohm's law, and I can bring that part of knowledge into the equation. So don't be afraid to say yes and. Yes, that's amazing, and let's also consider this aspect. Let's also consider what I'm bringing. I think that's part of the partnership that we've developed. I mentioned briefly that we both Monica's team, my team, and also our global human rights leadership team, we co-authored a paper for the IEEE, just trying to bring these three communities together so that we can each show that we have a complex series of challenges, and the only way that we will solve them and solve all of those constraints against all those boundary conditions is to bring the breadth of disciplines together. Now, what I'm so amazed of is the possibility of these tools. When my parents were just married, still in married student housing back when that was a thing, my mother made an investment, and she took her salary from Capital's department store downtown Logan and went to the K&E distributor and bought my dad, an aerospace engineer, fledgling, the most expensive slide rule she could afford. This was 1959. That was an investment in their shared future as a couple and the foundation of our family, and it made him a better engineer. And he had that slide rule, and he used it every day until he got his HP 35C calculator. And that changed it. That made him better able to live up to his dreams of landing, in this case, landing the Viking orbiter, or landing Viking mission on Mars, sending Voyager to the outer planets. We are now coming together to generate these tools that will not just make better engineers, they will make better engineers, they'll make better artists, they'll make better legislators, they'll make better politicians, and those of us that are embracing AI, we're not going to be replaced by robots, we'll be replaced by people who really are leaning in these technologies to augment themselves. And hopefully what you're going to take away from our conversation here today is we are being thoughtful. I still think there's so much for us to do to go and understand the full supply chain. I know this is something we wrestle with all the time. Always remind yourself, every supply chain ends in one of two places. It either ends in the sun or it ends in the earth. And as we mine, as we understand, as we pull this energy, it's either the light of our star or the light of stars long gone that is the source of all of our energy. That finite supply, understanding how we do these things, incredible things, but we want to do them with transparency. We want them with full accounting. And I am guardedly optimistic. I'll go that far. Guardedly optimistic that we are really cognizant of all of these forces, and we're really working and bringing our best to solve them. And that's what's going to make this something that we can apply universally. That's how we're going to make this an equitable global opportunity, is by working together. So I want to thank my panel for doing all this, and thank all of you for listening.